Electrochemistry deals with the relationship between electrical energy and chemical energy. Today we'll do some objective questions based on electrochemistry. Let's start with question number 1. Question number 1 is, electrical conductivity of electrolyte in aqueous solution is due to movement of. See, conduction is of two types, electronic conduction and electrolytic conduction. The question is regarding electrolytic conduction. Look at the options. First option atoms, second option electrons, third option ions, and fourth option molecules. So the question is, once again let me read the question. Electrical conductivity of electrolyte in aqueous solution is due to movement of. The correct answer for this is ions. In case of electrolytic conduction, the current is carried by ions. Ions means positive and negative. Cations and anions, they carry current. Cations move towards cathode, anions move towards anode, and in this way they carry current. The correct answer is third option. Question number 2. The SI unit of molar conductance is. Molar conductance is lambda m. It is given by this expression 1000 kappa by m. M stands for molarity. And he is asking SI units. Look at the options. Number 1, S per m per mole, S per m power minus 2, mole power minus 1, S m mole inverse, S m square mole inverse, and the correct answer is S m square mole inverse. The answer is fourth option. Question number 3. The specific conductance of 1 m sulfuric acid solution is 0.26. So specific conductance is kappa. It is 0.26. The molar and equivalent conductance of the solution are, see, molarity is given as 1 m, and the question is molar conductance is how much and how much is the equivalent conductance. See, we have an expression lambda m equals to 1000 kappa by m. If you put the values 1000 into 0.26 by 1, that comes to 260. This is molar conductance, and the equivalent conductance will be lambda eq is equal to lambda m by 2, because n factor of sulfuric acid is 2, so that comes to 130. So the correct answer is second option, 260 s centimeter square mole inverse and 130 s centimeter square equivalent inverse. So that is molar and equivalent conductance of the solution. So correct answer is second option. Question number 4. The distance between the two platinum electrodes of a conductivity cell is 0.8 centimeter. Distance is L. L is given as 0.8 centimeter. And the area of cross section of each electrode, A, is equal to 1.2 square centimeter. The cell constant is. Cell constant is given by this expression. Cell constant equals to L by A, length of the conductor divided by area of cross section. So that comes to 0.8 by 1.2, and the correct answer is 0.66 centimeter inverse. So correct answer is third option. You can see, because first option is given as 1.5, second option 0.96, third option 0.66, and fourth option is 1.5 centimeter inverse. So the correct answer is third option, 0.66 centimeter inverse. Question number 5. The specific conductance of 0.2 molar solution of weak electrolyte is 3 into 10 raised to minus 4 s per centimeter. There is a specific conductance. Molarity is given as 0.02, and specific conductance kappa is given as 3 into 10 raised to minus 4 centimeter inverse. Its degree of dissociation is 0.06. Alpha is 0.06. Its molar conductance at infinite dilution is how much? question is regarding lambda infinity. See, first you need to find out molar conductance at this concentration, that is equal to 1000 into 3 into 10 raised to minus 4 by 0.02. Then alpha is equal to lambda m by lambda infinity m. You substitute 0.06 over here, substitute this over here, and you can find out lambda infinity, and the answer you get is 250. So the correct answer is fourth option. Question number 6. The solution with higher molar conductivity among the following is. Solution with higher molar conductivity. First option 0.1 m acetic acid, second option 0.1 m chloroacetic acid, third option 0.1 m bromoacetic acid, fourth option is 0.1 m fluoroacetic acid. You know, all the solutions are 0.1 molar solutions, they have same concentration. We need to decide on the basis of strength of acid, and strength of acid is decided on the basis of minus I effect of chlorine, bromine or fluorine, and among them fluorine is the most powerful withdrawing group. So the most powerful acid among them is fluoroacetic acid, therefore its conductance will be highest. Answer is therefore fourth option. 0.1 m fluoroacetic acid will have highest molar conductance. Molar conductivities at infinite dilution of AgNO3, NaNO3 and NaCl are given as 116.5, 105.2 and 110.3 s centimeter square mole inverse respectively. The limiting molar conductivity of AgCl in s centimeter square mole inverse is. See, this is an application of Kohlroas law. Let us try to solve this. Lambda infinity of AgNO3 is given as 116.5. Lambda infinity of NaNO3 is equal to 105.2. Lambda infinity of NaCl is equal to 110.3. Now, lambda infinity of AgCl is asked, is equal to lambda infinity of AgNO3 plus lambda infinity of NaCl minus lambda infinity of NaNO3. So if you put the values, what value you put here? 116.5. What value for NaCl you put 110.3, and for NaNO3 the value is 105.2. So if you add these two and deduct 105.2, the answer you get is 121.6. So the correct answer is second option, 121.6. This is an application of Kohlroas law. Question number 8. 0.02 moles of acetic acid is dissolved in 200 ml of water. Its specific conductance is 5.46 into 10 raised to minus 4 s per centimeter. The ionic conductance of H plus and acetate ions are 349.3 and 40.7 s centimeter square per equivalent respectively. The degree of dissociation is n equals to 0.02, volume is 0.2, 200 ml is 0.2 liters, and then specific conductance kappa equals to 5.46 into 10 raised to minus 4. Ionic conductance of H plus is 349.3. Ionic conductance of acetate is 40.7. Now what is asked is degree of dissociation. Using these values, you can find out lambda m. and using these two values you can find out lambda infinity m, and the ratio of this to this gives alpha. Let's see. Lambda m equals to 1000 into kappa, that is 5.46 into 10 raised to minus 4 divided by molarity, 0.02 divided by 0.2. This gives molar conductance, and molar conductance at infinite dilution, that is equal to 349.3 plus 40.7. This gives lambda infinity. Alpha equals to lambda m by lambda infinity. If you substitute the values, you get the answer 1.4 into 10 raised to minus 2. So the correct answer is second option. Question number 9. What is the time taken in seconds to deposit 0.756 grams of silver when 1 ampere of current is passed through silver colorimeter? Atomic weight of silver is 108. First option is 548.5, second option is 583.5 seconds, third option is 629.5 seconds, and fourth option is 675.5 seconds. Let's calculate and find out how much time is taken for the formation of 0.756 grams of silver. We have this formula: weight of silver formed is equal to ECT by F. This is the formula, where E stands for equivalent weight of silver, C stands for current strength in amperes, T is time of passage of current in seconds, F is Faraday, that is 96,500 coulombs. So if you put all the values, 0.756 equals to 108 into current strength is given as 1 amperes, T has to be found out, and this is 96,500. If you put all these values and find out T, the value comes out to be 675.5 seconds. So the correct answer is fourth option. Question number 10. The time required for complete decomposition of 2 moles of water using 8 amperes of current in seconds is. You want to change 2 moles of water into H2 and O2. You get 2 moles of H2. Now, number of Faradays is equal to 4, because you are getting 2 moles of hydrogen, so that involves 4 electrons, so number of Faradays is 4. Now, current strength used is 8 amperes. The question is to find out T. You can use this formula, Q equals to CT, where C is current strength in amperes and T is time of passage of current, and Q is number of coulombs. So 4 into 96,500 gives rise to 8 into T. So T equals to 96,500 into 4 by 8. So that comes to 96500 by 2. First option. It is 4.825 into 10 raised to 4 coulombs. Answer is first option. Question number 11. On passing 10 amperes of current for 50 minutes, 6 grams of metal is deposited. The equivalent weight of metal is. See, 96,500 coulombs of current deposits one equivalent of substance. So let's try to calculate. Current strength given is 10 amperes. Time is 50 minutes, so it comes to 60 seconds. And 6 grams, weight of substance formed is 6 grams. So you can say 50 into 60 into 10 coulombs gives 6 grams. 96,500 coulombs gives how many grams? That becomes equivalent weight of metal. So 96,500 into 6 by 50 into 60 into 10. That comes to 19.3. So the equivalent weight of metal is 19.3. Second option is the correct answer. Question number 12. The standard potentials of Ag plus and Pb2 plus electrodes are minus 0.8 and plus 0.13 volts respectively. Which one of the following represents spontaneous cell reaction? See, E naught Ag plus is given as minus 0.8 volts. Actually, this is standard oxidation potential. So obviously E naught Ag plus oblique Ag will become 0.8 plus 0.8 volts. And then E naught of Pb2 plus oblique Pb, that is reduction potential, will be minus 0.13 volts. Now on the basis of this, you can say that Pb is more powerful reducing agent than Ag plus, than Ag, sorry. So the correct answer is Pb plus 2 Ag plus gives rise to Pb2 plus 2 Ag. That means lead will reduce Ag plus to Ag and itself gets oxidized to Pb2 plus. Its SRP of Ag plus silver electrode is higher than that of lead. So silver gets reduced and lead gets oxidized. As simple as that. So the correct answer is first option. Question number 13. The Nernst equation used for calculation of reduction potential of Zn Zn2 plus 0.1 m is, now look at the options. First option is E naught Zn2 plus oblique Zn minus RT by F log 10 raised to minus 1. Second option is E naught Zn2 plus oblique Zn minus RT into 2.303 by F log 10 raised to minus 1. Third option is E naught Zn2 plus oblique Zn plus RT 2.303 by 2F log 10 raised to minus 1. And fourth option is E naught Zn2 plus oblique Zn plus RT by 2F log 10 raised to minus 1. The correct answer is third option. This is as per Nernst equation. E equals to E Zn2 plus oblique Zn equals to E naught Zn2 plus oblique Zn minus RT 2.303 RT by NF. N is 2, so I can write it as 2F log 1 by concentration of Zn2 plus. So what I can do is change this sign and bring this to the numerator. So I can modify it to log of concentration of Zn2 plus like this. So this becomes Nernst equation for, and now this value is 0.1 m. So substitute this with 0.1, you get the Nernst equation. That is nothing but 10 raised to minus 1. So the correct answer is third option. Question number 14. Standard oxidation potential of copper Cu2 plus and Cu plus electrodes are minus 0.34 volts and minus 0.52 volts respectively. The E naught cell of the cell in which the following net reaction occurs is 2 Cu plus gives Cu plus Cu2 plus. Look at the options. First option is 0.88, second option is 0.28, third option is 0.18 and fourth option is 0.7. The correct answer is 0.18. You get it from the difference. E cell equals to 0.52 minus 0.34. That comes to 0.18 volts. Actually here the overall cell reaction is obtained from those two electrodes, Cu oblique Cu. See, E naught Cu2 plus oblique Cu is given as 0.34. I have reverted this, so that becomes positive. So 0.34 E naught Cu plus oblique Cu will become 0.52. So this becomes cathode, this becomes anode, and the difference comes to 0.18 volts. The correct answer is third option. Question number 15. Which one of the following statements is correct if E naught values for copper cupric and tin stannous electrodes are minus 0.34 volts and plus 0.136 volts? Let's see. E naught Cu2 plus oblique Cu comes to 0.34 volts. Again, I have reverted this, so the sign changes. E naught stannous oblique Sn, the value given is minus 0.136 volts. Now, the question, copper can be oxidized by tin, second option. Tin can be oxidized by cupric, third option. Stannous ions can be reduced by cupric, and fourth option is copper can be reduced by tin. The correct answer is Sn can be oxidized by cupric. See, cupric has greater reduction potential. It has a greater tendency to get reduced. Cupric tends to become copper by accepting 2 electrons, so it will transform tin into stannous. So the reaction which takes place is Cu2 plus Sn gives rise to Cu plus Sn2 plus. This is the reaction which takes place. Correct answer is second option. Question number 16. The standard oxidation potentials of copper and nickel electrodes are minus 0.34 and plus 0.26 respectively. When these electrodes are coupled to form galvanic cell, the standard Gibbs energy change of the reaction is, look at the values, E naught Cu2 plus oblique Cu is plus 0.34 volts and E naught Ni2 plus oblique Ni is given as minus 0.26 volts. Now, this will act as a cathode and this will act as anode, and the E naught cell will be 0.34 minus of minus 0.26. So, this comes to 0.6 volts. Now, we want to find out standard Gibbs energy change, delta G equals to minus NFE. So, that comes to minus 2 into 96,500 into 0.6, and if you multiply, you get the value minus 15.44 kilojoules. So, the answer is second option. Question number 17. Which one of the following is correct for the discharge of lead storage battery? See, during the discharge of lead storage battery, it behaves as a galvanic cell, and when this happens, in the reaction water is formed, so sulfuric acid is diluted. Look at the options, SO2 is liberated, sulfuric acid is diluted, PbSO4 is consumed, fourth option is Pb is formed. The correct answer is dilution of sulfuric acid due to formation of water. The reaction which takes place like this, Pb plus PbO2 plus sulfuric acid, it gives PbSO4 plus water. This is the overall reaction. So, you can see there is a formation of water which will cause dilution of sulfuric acid. Therefore, second option is the correct answer. Question number 18. In hydrogen oxygen fuel cell, the basic reaction is, first option combustion of hydrogen, second option conversion of hydrogen to hydrogen peroxide, third option is decomposition of water, fourth option is formation of oxygen from OH minus. See, fuel cell is a device in which the heat of combustion is directly transformed into electrical energy. So, in a hydrogen oxygen fuel cell, it is the heat of combustion of hydrogen which is transformed into electrical energy. So obviously it involves combustion of hydrogen. So the reaction which involves in hydrogen oxide fuel cell is H2 plus half O2 gives rise to water. This is nothing but combustion of hydrogen. So the correct answer is first option. Question number 19. Which one of the following set of products are formed during electrolysis of aqueous solution of KCl between platinum electrodes? See, if you use aqueous solution of KCl, it dissociates into K plus and Cl minus. At anode, 2Cl minus gives rise to chlorine plus 2 electrons. This is the oxidation reaction which takes place at anode. Chlorine gas is produced. At cathode, 2H2O plus 2 electrons gives rise to 2OH minus plus hydrogen gas. So the gas which is produced at cathode is hydrogen, the gas produced at anode is chlorine. OH minus is left out in the solution, K plus is also left out in the solution. Solution becomes rich in KOH, alkaline solution. So the products are chlorine, hydrogen and KOH. So the correct answer is second option. It consists of KOH, chlorine and hydrogen gases. Question number 20. Delta G naught for the reaction 2H2 plus O2 gives 2H2O in a fuel cell is minus 482.5 kilojoules. E naught cell is. So how much is delta G naught? Delta G naught given is minus 482.5. And we are asked to find out E naught cell. And look at the reaction. 2H2 plus O2 gives rise to 2H2O. So for this reaction, N equals to 4 because it involves formation of it involves 2 moles of hydrogen. So N is equal to N factor is 4. So the formula you are going to use is delta G is equal to minus NFE, or you can say delta G naught equals to minus NFE naught. The value given is minus 482.5. This is equal to minus 4 into 96,500 into E naught. So putting these values, you can find out E naught, and E naught comes to E naught equals minus minus gets cancelled. E naught comes to 1.25 volts. Question number 21. The standard reduction potentials of Fe, Zn, Cu and magnesium are given as minus 0.44, minus 0.76, plus 0.34 and minus 2.37 volts respectively. Which metal is suitable in protecting other metals from corrosion? See, the metal which has highest standard oxidation potential or lowest standard reduction potential will be the most efficient in protecting other metals. So you can see magnesium has highest standard oxidation potential. It has lowest standard reduction potential. That means it has highest standard oxidation potential. It is the most active metal. So most active metal will be most efficient in protecting other metals from corrosion. It itself undergoes corrosion. So you call it sacrificial protection. So the correct answer is third option, magnesium, because of its highest standard oxidation potential. Question number 22. Which one of the following aqueous solutions produce oxygen and hydrogen gas at the anode and cathode on electrolysis using platinum electrodes? Look at the first option, aqueous NaCl, platinum electrodes. At anode, this will produce chlorine, and at cathode, this will produce H2 gas. So this cannot be the answer. Next, AgNO3, aqueous AgNO3, platinum electrodes. At anode, this will produce oxygen. At cathode, this will produce Ag. Ag plus becomes Ag. So this cannot be the answer. Third option, aqueous copper sulfate, platinum electrodes. At anode, this will produce oxygen. At cathode, this will produce copper. So, even this cannot be the answer. Now, the fourth option, K2SO4, platinum electrodes. At anode, this will produce oxygen because a sulfate cannot be oxidized, and then at cathode, this will produce hydrogen gas. So, the correct answer is fourth option. Question number 23. Assertion is molar conductance of strong electrolyte solution increases with decrease in the concentration of solution. This is a fact. Molar conductance increases with dilution. Reason: the mobility of ions in solution of higher concentration is less due to large interionic attractions or formation of ionic atmosphere. This is the correct explanation. So, we can say the first option is the correct option. That means both A and R are correct, and R explains A on the basis of inter-ionic attractions. Due to more inter-ionic attractions at high concentration, the mobility of ions will get restricted. So, answer is first option. Question number 24. Assertion: 1 Faraday of current deposits 1 gram equivalent of copper or silver from the respective salt solutions of the metals. This is a fact. 1 Faraday will give 1 gram equivalent of substance. Reason: 1 mole of electrons are required to reduce 1 mole of cupric and Ag plus ions in their metallic state. This is not true. Actually, cupric requires 2 moles of electrons. You can see the equation. Cu2 plus 2 electrons gives rise to copper. So, 2 moles of electrons give 1 mole of copper. So, it is not necessary that every time 1 mole of electrons will produce 1 mole of metals. It is true in case of Ag, but it is not true in case of cupric. So, the correct answer is third option. A is correct, assertion is correct, but R reason is wrong. Question number 25. Assertion: when an iron nail is dipped in a solution of copper sulfate, after some time the blue copper sulfate solution becomes light green. This is a fact. Actually, what happens, copper sulfate consists of cupric ions. When iron nail enters into that, it will become ferrous sulfate and copper gets deposited. So, this is green colored substance. It is present in the solution. So, assertion, the statement 1 is correct. A metal with higher oxidation potential or lower reduction potential reduces the ions with higher reduction potential or lower oxidation potential. This is also correct. Fe, which has higher oxidation potential, will reduce copper, which has higher reduction potential. So, you can say the correct answer is first option, that is both A and R are correct, and R explains A on the basis of reduction potential values. Remember, SRP, standard reduction potential of copper, is greater than iron. Question number 26. Magnesium liberates hydrogen from HCl, aqueous HCl, but Ag does not liberate hydrogen when added to HCl solution. This is fact. Magnesium is present above hydrogen in the activity series. It reacts with HCl, aqueous HCl, and it will produce MgCl2 and hydrogen gas. Whereas Ag and HCl, no reaction. The reason is silver is below hydrogen in the activity series. So, first statement is correct. MgCl2 is reason. MgCl2 is soluble in water while AgCl is insoluble in water. This is also a fact, but this fact does not explain the first statement. It is not because of insoluble nature that AgCl is not reacting with HCl. So, the correct answer is second option. Both A and R are correct. R does not explain A. The explanation is not on the basis of solubility. Question number 27. Assertion A. In the cell with E0 cell less than 0, the cell reaction is always spontaneous. This is not true. EMF of the cell should be positive, then only we can say that the reaction is spontaneous. Now, reason: when a spontaneous reaction occurs, Gibbs energy decreases. This is true. Delta G is minus NFE. The decrease in the free energy indicates that the process is spontaneous. So, the correct answer is fourth option, where we say A is wrong and R is correct. Fourth option. Question number 28. We have in the list 1 we have various terms, in the list 2 we have units. molar conductance, specific conductance, electrode potential and cell constant. You know, the units for cell constant are m inverse, that is m is distance in meters, electrode potential is volts, specific conductance s per centimeter, and molar conductance is s centimeter square mole inverse. So, the correct answer is third option. A should be matched with 3, B matched with 4, C matched with 2 and D matched with 1. So, third option is the correct answer. I will write here molar conductance, the units are S centimeter square mole inverse. Then you have specific conductance kappa S per centimeter or S per meter, and then we have electrode potential E, the units are volts, and then we have cell constant. Cell constant is L by A, therefore, the units are meter inverse. Third option. Question number 29. In the list 1 we have various electrodes, and in the list 2 we have electrode reaction. Hydrogen electrode, then you have standard hydrogen electrode, then metal ion electrode, and then glass electrode. See, we know that look at the options, the correct option is fourth option, where A is matched with 4, that is hydrogen electrode is PT H2 2 bar pressure and then H plus at 0.1 m concentration. H electrode, it is being matched with this. Here PT offers electrical contact PT H2, and in the brackets we are writing the pressure oblique H plus 0.1 m. And then standard hydrogen electrode, here we have to have 1 atmosphere pressure and 1 molar concentration. So, you can write PT comma H2 1 atmosphere oblique H plus 1 molar. Then we have metal ion electrode. Fe oblique Fe2 plus, this is the metal ion electrode. Fe2 plus is in contact with Fe, and then glass electrode is used for pH measurement. Glass electrode is for pH measurement. So, the correct answer is fourth option. Well, with this we have come to an end of discussion. We have discussed some important questions on electrochemistry. Thanks. Thank you very much.